Alright, in our first lesson for the spring semester, we're going to talk about graphs of inverses. And we're going to switch the points. We're going to first plot the points from table 1. So I'm going to plot those in green here on my graph. So let's go and do that. And we have negative 2.25. Okay, negative 1, we're up at 0.5. 0, 1. 1, 2. 2, 4. And 3, 8. Okay. Now we're going to take that and we're going to draw a line through those points so that we can see what our curve looks like. That's step A. Step B, swap the x and y coordinates. So we now have 0.25 in x and negative 2 in y, 0.5 and negative 1, 1 and 0, 2, 1, 4, 2, just swap an x and y, and 8, 3. Okay, so now we've got those. Let's go back and plot those points on our graph. And I'm going to put those in pink. Okay, so we have at 0.25 we're going to go down 2, right there. 0.5 down negative 1. At 1 we're at 0. 2, 1. Okay. 4, 2. And 3, we're at, at 8, we're at 3. Okay. So there's those points. We're going to connect those. So we kind of have that graph on there. So that's our first two A and B steps. C, we plotted them. Now it says draw the line y equals x. Let me go ahead and show, though, that this is highlighted in pink so we can know which points go with which graph. Now it says to plot the points y equals x on the graph. So the y equals x line is the parent linear function, goes through the origin, has a slope of 1. So it comes through the graph like that. And that's an important line because that line tells us how we're going to relate or reference whether lines or curves are inverses of one another. So that's the line y equals x right there. Again, that's the parent linear function, if you remember that. Now look for a pattern. Take a minute. See what you see. Can you tell anything about these curves in relation to the line y equals x? And hopefully, since this is a recording, I'm not going to spend a lot of time, but hopefully you can see that these are reflections. Okay? So they are reflections over, okay, graphs are reflections over the line y equals x. Okay, so that's the pattern that we can kind of get from this. Okay. Now let's look at our next sample, our next example. And example 2 is that we want to do the same thing. Okay. So we're going to take these lines and we're going to put them, plot the first one, And then we're going to go and swap the points and plot the second one. So let's do that. Again, I'm going to be consistent, try to be consistent. And the inverse I'm going to highlight in pink, and the original relation in green. So let's plot these points. We have negative 3, 10. So that's way up here. Then we have negative 2, 7. Okay, 1, 4. 0, 1. 1, negative 2. 2, negative 5. Okay. 3, negative 8. And 4, negative 11, which is off the graph just a bit. And we're going to try to connect that with a green line. And I'm going to try to use my line tool here, see how that works. Okay. And so that goes from there. Whoops, I don't want it dotted. Well, okay. Go from here and draw a line through the points. Okay. So that takes care of that. Now we're going to swap the points. So we're going to swap the points just like we did in that graph on the top. So we have now 10. I don't want it in green though. I want it in black. So we have 10, negative 3. 7, negative 2. 4, negative 1. 1, 0. Negative 2, 1. Negative 5, 2. Negative 8, 3. And negative 11, 4. Okay. Plotting those points. At 10 we're at negative 3. 7, negative 2. 4, 1. Okay, 1, 0. Negative 2, 1. Negative 5, 2. Negative 8, 3. And negative 11, 4. Okay, so then we're going to try to put a line through that. Okay, so we're going to try to start here and connect the points. And we have another line. And I missed some of the points, but it's a pretty good line. Alright, so now the next step is put the line y equals x on there. And I'll put that dotted like I did before, going from corner to corner. And one thing, if you'll notice, it's I think personally, and this is just me, that it's harder to see that these are reflections over y equals x than it is to see that the curves in example 1 are reflections over y equals x. But they are, in fact, and we know that also because we've swapped the points. And that's one way you can tell if you have a graph of, if you're given a graph and you want to pick from a multiple choice like you might see on STAR, the graph of an inverse, get some points off the first graph, swap them, and find the choice on the second of the choices that has those swapped points on it, and that will be your inverse. There's a way to do it algebraically that we will do here on the next page. But since it's, I think, difficult to see that this is a reflection, another thing you can look for is whether they intersect on y equals x. And that's very obvious right here that these points do intersect on y equals x. So, are these two graphs. So I'm going to mark here that what we will notice is the graphs are intersecting on y equals x. Okay. So those are two things we notice from both these graphs. Now let's move on to our next page, which is, okay. Now, for some reason, I've lost a page. So I'm going to go to a blank page here and write out what should be on that page that I've lost. Alright, we've already decided, and you've got on the top of your notes, two graphs are reflections of each other over the line y equals x. Then they're said to be inverses of one another. You've got that in your notes. Highlight that or put a star by it. That's what we just saw as we did these graphs on the first set of notes, first page of the notes. Now we're going to learn how to find the equation of the inverse. So we're going to find the equation of the inverse, and there is of the inverse. There's basically two steps that you need to follow to do that. Okay, step one is swap x and y, and this is on your notes. But if you didn't print out the notes, then you have it here. Switch x and y in the equation. Okay. And then two, solve for y. Okay, which is much better writing than before. So I'm going to go back, even though it's maybe waste time, but I'm going to go back and write this a little better. Okay, so the first thing you want to do is you want to switch x and y in the equation. Okay, so now let's do some examples. Let's do an example so you can see what that means, because that's it's easy to say it and it's really not hard to do, but you may not quite understand. So we're going to, example 3 is, if you have the notes printed out, it's example 3. Y equals 4x plus 8. So step 1, when I mean switching x and y, what that means is that this y is going to become an x. Okay? And the x is going to become a y. And that's all we did, is swap them. And that makes sense, because what happened when you did the points? When you plotted points for the graph, you swapped them. You swapped your x's and y's, and that was the new graph. So this is swapping x and y's, and now you're going to have a new equation. The second one, what I mean when I say solve for y, is make it y equals everything else. Okay? So I have to take this number 1 here and solve it back, so I have y equals. So you subtract 8, you just now solve the equation for y. So x minus 8 equals 4y. Then divide by 4. So you have 1y. So y equals x minus 8 over 4. Now, if you need to graph it, you need to put it in slope-intercept form. So the way you're going to do that is divide each of these by 4, That's a 1x since there's nothing in front. So that's going to be 1/4 x minus 2. And that is y equals that. That would be an easy equation to graph. I will take either one of these answers. Okay? But this one is the one you're going to need if you have to graph your inverse. Okay. All right, let's look at a second example. And this would be example 4. Okay. So example 4 on your note-taking worksheet is f of x. In this case, f of x. This is functional notation. Remember, that's the same as y. And that equals 7 minus 5x. Now, what we're going to find when we have f of x is I want you to use the functional notation for the inverse. And so our inverse notation is f negative 1 of x. Now that doesn't mean it goes in the denominator like when we just did negative exponents. That is the notation that means we're looking for the inverse of f of x. But again, what we do is the process is the same. We're going to swap our x and y. So this y becomes an x equals 7 minus 5y. So x and y change places. And then you solve it. That's step 1. Step 2, you're going to solve it for y. So subtract 7. X minus 7 equals negative 5y, and then divide by negative 5. Okay? And so 1y equals x minus 7 over negative 5, or since we started with functional notation, you really need to have functional notation in your answer. So the inverse would be negative 1/5 x plus 7/5. And again, I'm doing it that way because at some point you're going to need to be able to graph these inverses. Now let's go back, and there was another example, 5. And 5 is a little problematic. These two have been linear examples where the highest power of x was, your highest power of x was x to the first, so there were lines. Here our highest power of x is a 2, right here. And that's going to mean that you have to watch out. That means you're going to have plus or minus in your answer. When you have that even exponent. So you're going to need to be careful. This is a be careful one example. Don't forget it. Okay, so again though, swap x and y. So here we have x equals 8y squared minus 6. Add 6 across. So 8y squared equals x plus 6. Then you're going to divide by 8. Same steps. This is pretty basic solving equations. Y squared is equal to x plus 6 over 8. Okay. Now you need to take the square root of each of these in order to get y. Okay. You're going to take the square root of both of those to get y. Well, the square root of y squared is y. But when we take that, then this answer is going to be plus or minus the square root of x plus 6 over 8. Or you could write it plus or minus the square root of 1/8 x plus 3/4. Reduce the fraction. And I will take, again, either one of those answers. This one is a preferable answer to me. Okay, so, but again, This is important. Okay, don't forget when you have that y equals x squared. Looks like that's two words. Okay. When you have the y equals x squared in some form, you're going to have plus or minus in your answer. So please do not forget that. So now as we go on to the next portion, we're going to again find an inverse, find the equation of the inverse and graph it on the graph, but we're going to also determine if these inverses in their original relations are functions. So we're going to answer this question about the original relation. I'm going to put the y equal x line on the graph for us. So we're going to go from here to here with our y equals x line, and we're going to graph y equals 2x plus 4. Alright, and remember that plus 4 means it's a y-intercept of 4, right there, and a slope of 2. So we're going to count up 2 and over 1, up 2 and over 1, up 2 and over 1, down 2 and over 1, and you can keep stair-stepping as much as you need to be able to draw a nice line. And I want that line to be green since it's the relation. So let's get that on there. We're going to start here and go down. So that is the original function as it was given. Now find the inverse. Now first, okay, next question. Is that a function? Well, vertical line test. Yes. Yes. That is a function. Alright, so now let's go and let's find our inverse. And again, first step, swap x and y, so that's x equals 2y plus 4. Subtracting 4 from both sides, you end up with x minus 4 equals 2y, because those had to be 0. Dividing by 2, x minus 4 over 2 equals y, or that's the same as 1/2 x minus 2. And that's a better choice since we want to graph it. And we're going to graph it in pink like we've been doing. Okay. And our answer to this question will be pink. And we're going to go over here and graph our line. So we're going to go to -2. And we have a slope of 1/2. And remember, fractional slope is not as steep. It's a flatter line than a whole number slope. So you should see as you go evidence that this is going to be a flatter line. And if you don't, you know you're doing something wrong. And so hopefully you'll start realizing these things and be able to catch yourself where you make mistakes. So let's look. We're going to put this line on there in pink, and it's going to go through these points. And notice that we have an intersection right on the line y equal x, so that indicates that we probably did find our inverse correctly. Alright, and so is the inverse a function? Well, vertical line test again, it's also a line, and all lines are functions. So that tells us that's the answer to number 6. Now let's look at number 7. Number 7 is a little different because on number 7, again, we're going to put in our y equals x line. Okay, and when we do that, we go from corner to corner. Okay, this is a parabola. So our original function we'll put in green, just like we've been doing with our original functions. We'll put the answer to question there, and that's a parabola. Now, you can calculate points, or hopefully you can remember that this 1 means that the whole parabola is shifted up 1, so instead of having its vertex at the origin, it's going to have a vertex right there. And since there's no number in front of the x squared right there, that's going to mean that it's not narrower or wider than the parent function. It is the same as the parent function. So we go over 1 and up 1 from the vertex, over 2 and up 4 from the vertex, okay, and over 3 and up 9 from the vertex. Okay, so we're going to draw that in. Yeah, and again, we're going to represent that in green. So there is, whoops, I don't need a line tool. That's not what I need. Because that's a curve. It's a curve. It's not a straight line. So we're going to draw this in here like that. Oh, I missed that last one, but anyway. Okay. So there's our parabola. The other thing you can do is find some points and plot them, and that helps you with the inverse. You have x that you choose, and x squared plus 1 is your y. So if x is 0, y is 1. When x is 1, y is 2. Negative 1 is going to be 2 again. Negative 2 is 5. Positive 2 is 5. And 3 is 10. Then when you go to plot your inverse, you can just swap the points for the inverse here. You can have 1, 0, 2, 1, 2, negative 1, 5, negative 2, 5, 2, and 10, 3. Okay, and that's going to plot our inverse. Okay. So let's go ahead and do that. We're going to have 1, 0, whoops, okay, 2, 1, and negative 1, 5, 2, and negative 2, and 10, 3, and then we always know we have the mirror image point, negative 3. And that's going to be our inverse graph that we're going to put here in pink. Okay. Now answer our questions. Is the relation, the green line, is that a function? Yes. And our inverse, is that a function? Well, from the vertical line test, you can see, no, it crosses those lines in more than one place. So no, the inverse is not a function. So just because the relation is a function does not mean its inverse is a function. And then on our next page, we talk about a horizontal line test. Well, what that means is you perform the horizontal line test on the inverse. On the original function. You draw horizontal lines, and I'm drawing them in pink because that's predicting the inverse, and you can see that it crosses that function in two places, these horizontal lines. So it fails, in this case, the original failing the horizontal line test means the inverse is not a function. Okay. So the original failing the horizontal line test means the inverse is not a function. Now, one thing we haven't done yet that was instructed of us is to find the inverse equation. So to do that, we're going to swap. So we'll have x equals y squared plus 1, subtract 1, y squared equals x minus 1. Square root both sides. Y is equal to plus or minus the square root of x minus 1. Okay, and so if you graph that on the graphing calculator, what you're going to have to graph, what you're going to punch in is y equals the square root of x minus 1, and y2 equals negative the square root of x minus 1. And that's how you could do it on the calculator if you wanted to see the graph on the calculator. All right. Now, we just talked about the horizontal line test in the previous slide. So here's a way that I want to show you the way you're going to do this if you're asked to predict whether a relation's inverse is a function or not. And that's all this question is asking. They don't ask for the equation of the inverse. So if you've forgotten the basic parent function, this is a cubic function. When x is 0, 0 cubed is 0. When x is 1, 0 cubed is 1. When x is 2, 2 cubed is 8. And when x is negative 2, 2 cubed is negative 8. So we can put those points on our graph. And it's going to look something like this. Okay. And I should have probably had negative 1. There's negative 1 on there. Now, is this relation a function? Yes, this is one of those common functions that we need to know. Even though it appears to be getting vertical, is it getting more vertical? It's not completely vertical. Now, looking at the horizontal line test to check for the inverse, and I'm going to draw them in because I can't point, but if you draw horizontal lines across, you can see that there's nowhere that original curve touches it in more than one place. So that means the inverse is also a function. And so the answer for this question is yes, the inverse is also a function, even though we didn't actually draw the equation of the inverse. Okay, that's the end of 1-2.